share.
Oh, there you go.
Okay, so we've got it now. Okay. I don't know why it delayed. Okay. So everything's okay now?
Yes, beautiful.
Yeah, we're
Okay.
watching it.
Okay, so solar minimum was December 2019, and here we are 14 months later, and we've really it's been kind of disappointing, I think, to a large degree. So what's going on here? And a couple of folks mentioned going into this, there've been a lot of predictions about solar cycle 25. And I don't like, there's two things I don't like about propagation and sunspot cycles. And in both cases, it's predictions. Because if there's any way to make a fool out of yourself, it's to try to either predict propagation in the short term, like tomorrow. What's the band going to be like tomorrow, or what's it going to be like in this coming contest weekend or whatever. You can really make a fool of yourself trying to do that, because you're almost guaranteed to be wrong. And the other way that's even more certain to make a fool out of yourself is to try to stand up and make a forecast as to what the sunspot cycle is likely to be 4 years from now. You're almost guaranteed to be wrong. So I don't take that approach. I take a little different approach that is more likely to be useful. And I think that's kind of the measure of both computer modeling, and I've done some of that in my career, and I helped Mark do some of the modeling for his successful WRTC competition, and that is models are always wrong. That seems kind of strange. Why would anybody go through the trouble of modeling if you know you're going to be wrong? Well, good models are helpful, but they're not necessarily correct. They're helpful, and they help you get to a successful answer where you couldn't rationalize without writing things down as to how to get to a successful outcome. So models are useful, and that's a reasonable measure, but models are usually wrong. Okay, so we're kind of in the middle here between the last sunspot cycle and then the solar minimum, and trying to figure out how we're going to get to what the sun looks like on the left side there with an active sun, and we're nowhere near it, unfortunately. So kind of a review, the solar cycle is actually 2 cycles, and some would argue 4 cycles. The northern hemisphere of the sun usually operates on a different time scale than the southern hemisphere of the sun. And that's very clearly illustrated in this visual. Just to describe this visual, the heavy line, the red line, is the smoothed sunspot number, which is a lot easier to visualize than the lighter line below it, which shows the instantaneous variation. So the smooth number is a little bit easier to understand. And then shown below, under that in green and blue, are the individual cycles for the northern hemisphere in blue and the southern hemisphere in green. And a very interesting thing happened during the last sunspot cycle. And that is, we started climbing up the cycle, and most people look at the smooth number for the entire sun. And the first peak in 2012, 2013 was a very disappointing peak. 10 meters was really poor. But if you look in detail, you could see that it was the northern hemisphere that contributed to that, and it was fairly weak. And then the sunspot cycle started to go down, and everybody was worried that we were heading to solar minimum early. But then the southern hemisphere kicked in, and it was strong enough and persistent enough that 10 meters was pretty good for a couple of seasons. And then we went down to solar minimum. So it's very important to look at both of these hemispheres separately. And one of the contributors to weaker solar cycles is when these 2 hemispheres do not line up. I think you can appreciate that if you looked at the last sunspot cycle, and if the blue line were lined up with the green line, then the total sunspot number would have been significantly higher. But in the last sunspot cycle, the 2 cycles were almost perfectly out of line, which contributed to the problem. And the other thing I want you to look at, this is very important, is if you look at solar minimum in 2009, And you went another year later to 2010 as we were climbing out of that solar minimum, going into cycle 24. Notice that both the blue and the green lines were growing similarly, not identically, but you could see that the green line, the southern hemisphere, which ultimately was late, was growing more slowly than the blue line. This is very significant, so pay attention to that. If we were in person, I'd stomp my foot because this is very important. And here's another way to look at the same thing. These are the 13-month smooth sunspot numbers, and this graphic comes from a very useful website, the SILSO website at sidc.be/SILSO. There's lots of interesting information on this website. And the way this graphic works is that the green line is the northern hemisphere, and then the excess sunspot activity over and above the northern hemisphere is shown in red. So you can see from this graphic presentation of the same material that was in my slide originally, or the previous slide, you can very clearly see what happened in the second peak of the last sunspot cycle when the southern hemisphere really kicked in. And you can also see it in 2009, 2010, how both cycles were climbing slowly, but climbing. And here's a little bit of a longer term view historically. There was a 55-year period of unusually high sunspot activity if you look at the long-term history of sunspots from 1955 until 1957 to 2002. It's a 55-year period. Some people refer to that as the modern maximum. And these were the years when we had really great 10-meter openings during each of these cycles. And the peak of the cycle with the solar flux at least 100 persisting every day, day after day after day for 5 years was kind of what we got used to. And then after 2002, when we dropped down to the solar minimum after cycle 23, we had this weak cycle 24, and then all these prognostications, which I will not do, associated with cycle 25. And we've been through another very long, low period between these solar cycles. We had 817 spotless days during the 2009 minimum, and we're going to probably, well, almost certainly have more than that during this minimum. For those you haven't noticed, and I'll get into this in a little bit more detail later, but with this year, 2021, about half the days this year have been spotless. So that's kind of a setback from where we were in the CQ Worldwide CW in November, where we had some fantastic propagation. And here's another one of these forecasts that I generally distrust. And this is the consensus forecast for cycle 24 by a team of people that came together about 18 months ago. And their forecast is sunspot cycle similar to cycle 24. But notice they don't make any attempt to deal with this issue of the northern hemisphere and the southern hemisphere potentially being out of sync. So if their forecast is assuming that those two hemispheres are in sync, then this sunspot cycle forecast would be much worse if the two cycles are out of sync the way they were for the last several cycles. And another way to look at what's happened, the last sunspot cycle 24 sunspot occurred on July 4th last year. And that was it. There's no reason to expect we're going to get any more. And if we, in the unlikely event we did get the odd sunspot from the last cycle, it probably wouldn't contribute hardly anything at all. So we're climbing out of this slow period. So what happened in the fall? These are the daily solar flux index. I'm sorry. These are the daily sunspot numbers starting in September and running through now. And you can see, and I don't show any data before September because it was flatlined at a very low number. But starting in September, there's the solar flux index, sorry, the sunspot number started to increase gradually. And then a few days before the CQ Worldwide CW contest, it exploded. And we had 10-meter openings both days. My station was multi-single, as you heard from Mark, but even under the restrictions of multi-single, where we pretty much worked only multipliers, we worked nearly 70 countries as a multi-single on 10 meters, and we were spending relatively little time there. So what happened? But the other thing I want you to notice here is after that CQ Worldwide CW peak, things declined, and that second peak at the end of December, that was that very powerful sunspot that popped up for CQ Worldwide CW coming around again. So that was round 2 for sunspot number, I think it's 12786. Coming around again at Christmas time, weaker, and then it came around again in January. So let's take a look at the composition of this. So we talked about the north and south hemispheres. So in green, you can see that all of this activity that we've seen in the solar cycle so far, all this activity that we enjoyed last fall, was contributed almost exclusively by the southern hemisphere. Almost everything, and in fact, most of it by just a single sunspot region, a very large sunspot region, and very, very unusual to have a powerful sunspot like that only 11 months after solar minimum. So one has to ask, and nobody knows the answer to this, was that an oddity that this very powerful sunspot showed up for CQ Worldwide CW and repeated it at Christmas time and then repeated last month, weaker each time? Was this an oddity, or is this a progenitor of good things to come? And nobody knows the answer, but there's reason to be concerned. So here's the northern hemisphere in blue. The northern hemisphere is still in solar minimum. And if you remember the graphic I asked you to look at for solar cycle 24 as you climbed out of the minimum, the southern hemisphere solar activity picked up in a similar rate to the northern hemisphere solar activity, but that's not happening so far. So far, we've had this one very powerful sunspot that popped up for the southern hemisphere, and the northern hemisphere is still in solar minimum, now more than a year later. And now in 21, half of the days in 2021 have been spotless. Now here's one more aspect that I won't get into a lot of detail with this. So nobody knows what's going to happen over the next couple of years, but I'll give you a couple of clues on the next slide. The other thing that happens as the solar cycle starts to pick up is that we also have a lot more days with geomagnetic storms. Over the last 4 years or so, to the extent that we've had geomagnetic storms, they've generally been rather weak, which means they affect mostly high latitude propagation, and they've generally been short. They last a few hours typically, and they don't clobber an entire contest weekend. But as we go up the sunspot cycle, if we have a larger cycle like solar cycle 23, we'll have more of these geomagnetic storms, and they will be more powerful. So if you look, for example, at the peak year of 2003, you'll see these darker colors up here, and these are the more powerful strong and extreme storms. And if you look at the weak sunspot cycle we just came out of, You can see the double peak in that cycle, but now we're looking at the peak in a different way. We're looking at the frequency of geomagnetic storms. You can see that higher peak in 2015 had more storms, but only a third as many solar storms in that weak second peak in 2015 as there were in 2003. So we're going to have some good news from this new cycle, but we're also going to have some pretty bad days. So this is my last slide, and this is really kind of the bottom line here. Nobody knows what's going to happen this year, but we'll have a much better idea as to what to expect over the next 3 years by observing what does happen this year. The second year of the sunspot cycle is the telling year about what's going to happen for the next 3 or 4 years as we go to solar maximum. So by the end of this year, the solar flux index, notice I've changed now to solar flux index rather than sunspot number. The solar flux index should be persisting at least 100 if we're going to be having a sunspot cycle similar to cycle 24. However, if the solar flux index is persisting, and by persisting I mean for several months, where the solar flux index gets to be 100 or 125 and stays there for day after day after day, for week after week, that's what I mean by persistent, not some solar flux index that goes to 100 today, back to 80 tomorrow, went up to 100 for a few more days and back to 80. By persisting, I mean it gets to be 100 and stays there for week on end. So if we're persisting at about 100, that's a progenitor that the sunspot cycle is going to be similar to the last one. If we persist below 100, that's bad news. Things are progressing very slowly. In order for that to happen, that's probably going to mean that that northern hemisphere that's still asleep, somebody kick it, please. But that northern hemisphere that's still asleep is probably still going to be asleep in order for us not to have solar flux index persisting at 100. If, on the other hand, and this will be a very good outcome, if we get through November and December and every day is sitting at 125 and above, that means that we're heading for good times. So let's hope that's the case. And that means not only are the numbers going to be bigger than some of the forecasts that are around, but it also means the solar flux index is increasing rapidly. So not only are the numbers bigger, but the rate of change is faster. We've got a long way to go from where we are now with solar flux indices around solar minimum numbers, low 70s, in order to get to persistent numbers of 125, let's say, during the entire month, every day of November and December. That's a long way from now. So let's take a look at what's likely to happen to propagation. So if the solar flux index persists at 100 or more in November and December, we're likely to see nighttime propagation on 20 meters much more frequent. If you listen on 20 meters at night right now, it's pretty poor. That's because we're basically back at solar minimum again for a while. So once we get to persistent numbers of 100, 20 meters will become a nighttime DX band again. It won't be open all night with solar flux persisting at 100, but we'll have some pretty good openings at night. 15-meter DX from October through May during the daytime will be more frequent and more reliable at a solar flux persisting at 100. And 10 meters, unfortunately, doesn't benefit very much from solar flux indices around 100. So we'll get sporadic openings here and there. They'll be unreliable. You have to be really on your toes. And the good news is when the solar flux persists at 100, there'll be days that are higher. So chances are the days that we'll have some 10-meter propagation will be those days when the solar flux peaks up to numbers more like 120, 130 for a few days, and then drop down to the persistent level of 100. So what about solar flux indices of about 125 or more? So if we accelerate to that level by the end of this year, nighttime DXing on 20 meters will be frequent at night all year round. And the openings that we had gotten used to on 20 meters at night to work VKs and ZLs at 2 o'clock in the morning, those openings will come back. And at this number also, we'll start to have some of these middle of the night openings to Europe on 20 meters. It's very common with these high solar flux indices for 20 meters to be wide open to Europe at 3 o'clock in the morning. Big rates, much better than the daytime rates. Now, even if we have a very, very weak cycle, at some point in a very weak cycle, we should get to a point where the solar flux persists at 125. It's just that it won't be very reliable if we have a very weak cycle. So what about 15 meters? Well, 15 meters will be quite frequent during the day from October through May. So 125 is a pretty good solar flux number for 15 meters for daytime. And 10 meters is not too bad also. Now, 10 meters likes to have solar flux indices more like 150 rather than 125. So if we're persisting at 125, then we'll have occasional days when the solar flux jumps up for several days up to numbers like 150. And those will be the days when 10 meters gets to be pretty good. And the last case is when the solar flux persists at 150 or more. During the last sunspot cycle, cycle 24, which was a weak cycle, you remember the second peak, which was the peak driven by the southern hemisphere of the sun, we had about a year when the solar flux index was persisting at 150 or more. And during that year, 20 meters at night was fantastic. It wasn't so good in the daytime, but we had some pretty darn good openings to Europe in the middle of the night and lots of excellent openings to VK and ZL during the middle of the night. 15 meters was very, very good during that period when we had the solar flux at 150 or more. And 10 meter daytime DX was much more frequent from October through May. But unfortunately, this period of persistent 150 only lasted for about a year or 18 months. So that's what's in our future, and that's what the end of my presentation. So I think the theme of my presentation is, number one, somebody needs to find a way to kick that northern part of the solar hemisphere to get it to wake up again, because we don't have any idea what that part of the sun is going to do unless it starts to wake up and show a little bit of its power. So far, it's a weakling. And second, the southern part of the hemisphere was showing us what it could do, especially in November. But now it's settled back down again, and it's also very quiet. So the next 10 months are going to be very, very telling. We will, with high confidence, be able to estimate what the rest of cycle 25 is going to be by late this year, when we see what the persistent values of solar flux are. And from that, we will be able to project with high confidence what they will be over the next couple of years. So that's the end of my presentation. I hope there are some questions. I'm sorry.
Rich, maybe you ought to ask Frank your question. I see it posted there, but it's quite lengthy. So why don't you ask it?
I'm not going to try to read the question. So if you have a question, please turn on your microphone.
Yeah, Rich, NN3W, you've got a long question there. Why don't you ask it?
Okay. Hey, Frank, and hey, everybody again. Frank, I saw your presentation today, and also during the propagation symposium a couple weeks back. I guess going back probably 50 or 60 years, there have been a fair amount of predictions about what future sunspot cycles will hold in terms of how big they're going to be or how prolonged they're going to be. It's not too dissimilar from hurricane projections. You know, for example, you get people who project out 6 months out, this is what the season's going to be like. Then you have models that project individual storms, and some models seemingly have tended to, I guess, what you would say, get it better than other models. Based on your past experience of looking at some of the models, are there any of the particular models that have been more correct in terms of solar cycle, solar flux prediction for the upcoming cycles, going back, 23, 22, 21, 20, or 19? And if for those models that were correct, in your opinion, what have those models been predicting for cycle 25?
Rich, the bottom line is I don't trust any of them. So my recommendation would be to watch what happens with the solar flux indices over the next 6 to 8 months, and tuck away a copy of this particular slide, and then you'll be able to do your own predictions far more accurately than any of these predictions that are out there. We know a few of them are going to be right, but we won't know which one of them is going to be right until about a year from now.
I have a question, Frank. I recently read some stuff about a new 11-year plasma model of some kind to explain sunspots. I don't remember the details, except that I remember not completely understanding the article. Do you have any knowledge about that new plasma model and how it may affect predictions, which you don't like to do?
No, I don't like to do it. No, I haven't read that paper. Our sun is, was it 5 billion years old? And we've been observing sunspots in detail for a few hundred years. And we've been trying to model the sun for a few decades. And we've had computer models powerful enough to do that even better for 10 years. And, maybe in a few thousand years, we'll know how to do this. But at the moment, we're just guessing. So my recommendation is to set all that stuff aside, print this page, fold it up in your pocket, and take a look at it later this year.
Thanks.
Frank, this is W3LU Steve. What will it take for 6 meters? The cycle before this, boy, on that second peak, it was just worldwide, just about every day on 6. And what does it take to drive that again?
Yeah, well, there's some. Hi, Steve, thank you for that question. That's a really good one. I enjoy operating 6 meters too. Well, number one, don't wait, because June and July are fantastic for 6. And I know some people are going to kick me when I say this, but the mode to be on 6 meters in June and July is FT8. I think K2YWE's dog is ready for that season. So don't wait for solar cycle 25. Get on and enjoy June and July. How good can it be? Last June and July, I worked 500 Europeans and I worked 100 JAs using sporadic E in June and July. So put your money there.
Yeah, FT8 became the magic node on the magic band for getting into Europe and everywhere else compared to what it used to be.
Yeah, well, that's because of activity. It's all about activity. So back in the day, when I and others were doing 6-meter DXing mostly on CW, there was a limited audience of CW operators. But now that FT8 is almost the exclusive mode for 6-meter DXing, the pool of potential people you can work is orders of magnitude bigger. So the openings appear to last longer. They appear to be more frequent. But my postulation is that what's really happening is, first of all, the situation awareness is much better. So people are much more aware that the openings are taking place. And secondly, that the pool of people you can work is much bigger. So I wouldn't wait for solar cycle 25. Something useful might happen. Solar flux has to persist at levels well above 200 in order for 6 meters to become a regular aspect. Now, and that's for F2 propagation. But let me mention one other thing. There's a mode of F2 propagation that people often forget, and that's called transequatorial propagation, TEP propagation. That takes advantage of bands of enhanced F2 ionization that exist 1,000 miles north and 1,000 miles south of the geomagnetic equator. What the hell is that? Well, everybody knows, I think, since we were in elementary school, that the Earth doesn't, that our compasses don't point at the geographic equator, they point at the magnetic equator. And the Earth's magnetic field has a very, very large impact on the ionosphere, especially in equatorial regions. So that causes a concentration of electrons near the geomagnetic equator. By near, I mean 1,000 miles north and 1,000 miles south. That creates a tilt in the apparent profile of those two intense areas and allows something to happen that's called chordal propagation, C-H-O-R-D-A-L, chordal propagation, where a signal goes up from Florida. Let me say that again. Where a signal goes up from Florida, up to one of these very intense areas of F2 ionization, and then it skips through the ionosphere without any other reflections until it hits that other very intensely ionized area south of the geomagnetic equator, and then comes back to the Earth in Buenos Aires. Let me say that again. Comes back to the Earth in Buenos Aires. So this is a fantastic way to communicate from Miami to Buenos Aires, even with modest sunspot cycles, and it is F2. So how does that relate to us? Well, if we get very lucky and we get a sporadic E opening from Maryland to Florida, that's not unusual, is it? We work Florida stations all the time on 6 meters. So if we get a very good sporadic E opening from Maryland to Florida, we can then couple into this transequatorial F2 propagation. And how good can it be? Let me just describe a QSL card that I got from a fellow in Buenos Aires. This was an exceptional day on 6 meters. It was about 8 years ago, as I recall, during the peak of the last cycle. So we had solar flux numbers around 120, 130 probably. I don't know what they were that day. And the signals from Argentina were stronger than all of the local stations on 6 meters. K1RZ is 10 miles from me. He runs 1,500 watts. Some of the stations from Buenos Aires were louder than K1RZ. That's how efficient this mode of propagation is. I got a QSL card about a week after, and it was the fellow included a photograph of his station, and it was 5 watt. It was a CB single sideband transceiver, a little mobile transceiver, 5 watts, converted to 10 to I guess, well, I don't, maybe it was a ham one, but in any case, it was a 6 meter, 5 watt, little tiny transceiver that you might put in your car, sitting on his patio table at ground level with a little loop antenna sitting on top of the 5 watt radio. And he worked me by this F2 mode. And I remember that contact. He was not weak. It was an easy contact. He wasn't like K1RZ, but that'll show you what F2 can do on 6 meters. And that is F2, and it was in the last sunspot cycle. So I would be delighted if by the end of this year, if we see persistent solar fluxes above 125 in November and December, that is really good news about the rapid rate of increase. And if you see that at the end of this year, then put on your seatbelts, because we might start seeing 6 meter propagation by 2 years later, like 2023. If we see persistent solar flux below 125, forget about it and start thinking about June and July every year. And it's great. I've worked 125 countries on 6 meters almost exclusively by sporadic E. That was a long answer to a short question. Sorry about that.
Frank, this
Yeah.
is Zori, KB3VQC. Beautiful presentation. In reading about the cycles and activities, a number of experts are talking about 22-year cycles, and I couldn't help but feel while looking at a couple of your excellent slides that showed 3 and 4, and I think in one case at least 5 cycles, that there seems also to be some cycle activity beyond 22 years. May I ask your thoughts on these additional longer cycles?
Yeah, thanks for that question. That's certainly true. And I can email you some slides that show that. But if we look kind of here, you can see one of those cycles happening. We went through this 55-year period called the modern maximum from about 1955 to 2002, and that's over. It's probably not coming back. I hope it does come back, but it's probably not coming back anytime soon. But there's a cycle called the Meissenberg cycle, which I think is a 400-year cycle. There's another 100-year cycle, and I can send you a graphic that shows some of those. I just didn't happen to put them in this presentation.
Thank you, I'd appreciate it.
A3Q here with a question. Frank, I've seen a few of your presentations recently, and if I understood it right, you recommended a 50-foot height for your 6 meter beam to work DX on FT8. And I'm wondering, is there something special about 50 feet, or is it more like that's enough, you don't really need to go higher, or what?
Yeah, hi, Rich. Thanks for that question. Well, so let's think about comparing 6 meters maybe to 20 meters. So a 50-foot high antenna on 6 meters is at the same height above ground in wavelengths as a 180-foot high antenna on 20 meters. So that's pretty high. So, and of course, both of those antennas, a 180-foot high antenna on 20 meters and a 50-foot high on 6 meters, produce signals at the same radiation angles. So in terms of wavelengths, they're at the same height. So, and I think most of us would generally think that it isn't really worth the trouble of putting up a 400-foot high antenna on 20 meters. And it's true, don't do it. And the same is true on 6. And one of the reasons I'm very confident of that, Rich, is I not only have that big 6-meter beam on at 50 feet. My neighbor originally had his 6-meter beam at 120 feet. And I won't get into the details, but I convinced him to reduce it down to 70 feet, and it's working significantly better. But I also have another 6-meter beam, and it's 150 feet high. And it's almost never better than the one at 50 feet. So, you know, I haven't experimented with antennas at a whole variety of heights, but I can tell you with high confidence that antenna at 50 feet is more reliable than the one at 150, and that my neighbor W3UR has not regretted the day that he reduced the height of his 6-meter antenna from 120 to 70. I haven't suggested to Bernie that he reduce it to 50, but it might be even better at that height. But he does great with his 6-meter antenna at 70 feet. So
Got it. I got a follow up.
That analogy to 20 meters might help you kind of think through that.
Absolutely. I've got a follow up though. We've noticed skew path on 10 meters. If you have a relatively high 10-meter antenna, is that not possible on 6?
Anything's possible. You know, in the world of propagation, there's all kinds of edge cases where, you know, things happen once or twice, or maybe once or twice a year. So the scatter modes on 6 meters, the ionospheric scatter off azimuth modes on 6 is something I've never experienced. But I've never experienced a big sunspot cycle like we had back in 1957. I was only 10 years old then. So I've never experienced that. So about all I can say is that for the recent sunspot cycles, I'm not aware that this off azimuth propagation exists on 6 meters, but it probably does. It's just a matter of the ionization getting to be very, very strong. And what's happening there? So let's go back to your 10-meter example. For those that have operated 10 meters with a decent antenna, and a decent antenna on 10 is anything 50 feet high or higher is pretty darn good on 10 meters. Normally, when we work Europeans on 10, it's via the direct path, and they're real strong, pointing directly northeast, right through the center of Europe. But late in the opening, or before the, well, it's an even more common case is before the opening develops fully. So normally a good 10-meter opening begins shortly after sunrise. But in the 30 minutes or so before the opening fully develops, very often we'll point our antennas at Africa rather than at Europe. So that's a scatter type of propagation rather than a direct reflection off the ionosphere. And that scatter is probably off of ground-based objects like very big ocean waves or very large land objects. And they're very inefficient modes. But if you're running kilowatt power and big sunspot numbers, then the ionosphere can be efficient enough between here and Africa that a very weak scattering off of the ground in Africa will cause signals to scatter back through the ionosphere up to Europe, and that'll allow that to happen. So that's a pretty common mode on 10. I haven't experienced it on 6, but probably somebody who was real active on 6 meters 2002 and before, like K1HTV, for example, I wouldn't be surprised if Rich would tell you that that opening exists. I just haven't experienced it, but it should be there. Let's hope for. So now you know, Rich, that what you want to look for this year, if we're going to see if this mode exists, is we need to be looking at persistent solar flux indices of 125 and more in November and December. And if that's the case, get your 6-meter station ready, and we'll have some fun.
QSL, thanks. Yep, I'm working on it.
But don't wait, you'll have some fun in June and July too. Don't forget that. We don't need no stinking F2. We can do plenty good with sporadic E and FTA. Where's Lucy?
I have a question. It's Eric, W3DQ.
Yeah, go ahead.
Yeah, Rich mentioned a comparison with weather forecasting and meteorological forecasting, and I'm curious to know how the technology is changed, or is the work that's going on now, are the models getting better at any level? I mean, are they becoming more accurate or more detailed, or what's going on in propagation science?
There's a lot going on in propagation science, much more all the time. And it's driven by, to a large degree, a lot of government funding associated with the mission to Mars. Because the astronauts who are going to Mars need to have very excellent warnings of disturbances on the sun that could kill them on the surface of Mars. So they need warning to be able to get to a safe place. And they need these very intense disturbances, the protons. Well, the electromagnetic waves from the sun, I don't know what the transit time is from the sun to Mars, but let's put that aside for the moment. But from the sun to Earth, it's only 8 minutes for the very powerful electromagnetic stuff. And for the proton radiation, which is very harmful from solar flares, the proton radiation takes about a day or less. So this science is extremely important to the safety of astronauts on the surface of Mars. So there's a lot of money being spent, and a lot of money being spent on forecasting. But most of the interest there is not so much the long-term forecasting as it is the almost nowcasting. What's happening on the sun? And you know, there's a big problem, because if you use my approach, which is based on observations that I've already explained to all of you how to be expert observers this year. Unfortunately, the speed of light means that we can't see a disturbance on the sun until, on the Earth, we can't see it until 8 minutes after it happened. So we don't know what's actually happening, even as observers, because we're limited by the speed of light. So that's not very helpful to the safety of anybody on Mars that's not protected by a powerful magnetic field the way we are on Earth. So to answer your question, a great deal of money is being spent on solar physics. A great deal of money is being spent on forecasting. But I don't think any of that's in time to produce a forecast that we can depend upon for solar cycle 25. Maybe for solar cycle 26. So bring up that question again in another 11 years.
I'll mark my calendar. Thank you very much.
Okay. And let's pray for the safety of the astronauts on Mars. They'll be there by then.
12 minutes.
Okay, so I guess that's it. Thanks everybody for your interest. Pay attention to those solar flux indices, and let's pray for persistent 125s or above starting November 1st. Oh, and kick that northern hemisphere of the sun. Because if that persists the way it is now, forget about it.
Well, thank you very much, Frank. Very good presentation. And I had some pretty good questions there too. So very enlightening. So I'll remember to I was surprised with my crappy station. I was able to hear Europe on 6 I think it was in that same period. So that was pretty amazing. So I'm going to take back presenter, and we're kind of going to finish up here.